Hello guys, it's the tutor here, and in this video I'm going to introduce you to integration of exponential and trigonometric functions. This is a very simple introduction as these two types of functions tend to get very complicated in calculus, especially when it comes to the area of integration, which we will cover more on as we keep going. So to start off with the most used exponential function, the natural, e to the x dx. So the integral of this is just e to the x plus c. And the reason is, if you think about it, is that the derivative of e to the x is just itself. And if integration is the reverse process, it would make sense that it would just be the same thing again. Now, for a more traditional exponential function, such as b to the power x, b being some constant, right? Then you have the integration of that will be equal to the exponent itself, to the exponential function itself, divided by ln b plus some constant, right? And now to the more interesting one as well, the cos and the sine one are very similar in idea to the e to the x integration, where cos x dx is equal to sine x plus c. And if you think about this one, the derivative of sine x is just cos x, right? So if we want to go backwards, same thing. Now, sine x dx, however, is interesting because it's negative cos x plus c. And if you think about it, that's because cos x, right, of cos x is negative sine x, right? So we have to have a negative sign somewhere to compensate for that. Now let's do some examples, nothing crazy. So in the, over here, it says e to the x is equal to e to the x plus c. But here we have e to the 3x, right? It's not the same thing, but not to worry, we can do a simple trick. So the integral of 3 over 3 times e to the 3x dx is still the same thing, right? Because that 3 over 3 just cancels out to 1, no? So what you can do now is you have, this is a bit of a substitution, but nothing crazy, right? Because now what you can do is, since the e to the 3x is here, and the derivative of it is, the derivative of the exponent is also there, you can just take it. So this is just equal to e to the 3x over 3, right? Now let's work backwards to check our work. So the derivative of e to the 3x over 3 plus c is equal to, c would just be 0, right? So then it would just be e to the 3x times 3 over 3. And this is right what we started with right here, right? Let's do sine 4x. Can you guess what we have to do? Well, similar to what we just did, right? We just multiply it by 4 over 4 in this case, right? So we're just going to do the same trick. This is a very popular trick. This, you will have to do this in your homework problems and in your, even on your test. This is very popular, right? So now that we have the derivative here, the derivative of the inside there, right, we can easily do it. So from our identity list, we know that sine x is right there, right? So it's going to be negative cos x. So x, we're going to have it this thing. So we have negative 1 over 4 cos 4x plus c. Now let's double check, right? Because it could get confusing with these, and even I get confused. So let's just double check. Cos 4x plus c, right? There, that would just be 0. Negative 1 over 4, right? It would be negative 1 over 4. So there's a little bit of chain rule. Sorry. It'd be, what am I saying? Yeah. It'd be times negative sine, right? So this would become positive. Be sine x, sine 4x times the derivative of the inside, so times 4. cancels out. You get sine of 4x. All right. Now let's do a cos one. Well, this one, look, they already give us the 3. So all we have to do is just we go back to our identity list. Cos x is just equal to sine x, right? So we just got here sine of 3x plus c. That's it. Let's do some ease. Got the derivative right here. We're good. E to the 18x plus c, 3x. Okay. So here, for this one, as we recall, this is what we're looking for, right? To b to the x over ln b plus c. Let's write that down here. B to the x over ln b plus c. Was that it? Yeah. So let's apply it. Our b is 3. B equals 3, right? 3 to the x ln 3 plus c. Very easy. Now, this one, 3 over 2. Nothing to be worried about, right? Doesn't matter if it's fraction, whatever, right? Our b is equal to 3 over 2. So we have 3 over 2 to the x over ln of 3 over 2 plus c. That's it. So yeah, I hope this introduces you guys to the basics of integration of exponential and trigonometric functions. In the next video, we'll be doing some more complex examples that will require u-substitution, more complex u-substitutions, because we did a little bit of them, but nothing crazy. Other than that, if you guys have any questions, leave them in the comments or not. Have a good day.